Example 6 says, for the curve y equals x to the third, a, find the line that is tangent to the curve at the point 1, 1. So when x is 1, y is 1. So we know the point, guys. The tangent means the tangent line, so we need a slope. To find the slope, remember, we now know two different ways, right? The formal definition of the derivative and the alternative, which is the derivative at a point. So we can go and use the alternative definition, which is the limit as x is approaching an unknown point, let's call it a, f of x minus f of a all over x minus a. So x, which is going to be, guys, your a is just going to be 1, and your f of a is going to be 1. So a equals 1. F of a, by plugging it in, 1 to the third is 1, or in this case, they already gave us the point, which is going to be 1. So we are going to say x to the third minus 1 all over x minus 1. This is a difference of cubes, so your factoring is going to be x minus 1 times x squared plus ax, which is 1 times x is x, plus b squared, so it's going to be 1 all over x minus 1. Okay, so these are going to be reducible. So limit as x is approaching a is 1 in our case. Okay, we have x squared plus x plus 1. So by substitution, 1 squared plus 1 plus 1, our slope is currently coming out to be 3. The tangent line, we're just going to leave it in point slope form. Y minus 1 equals 3 times x minus 1. So B says find the line that is normal to the curve at the same point. Remember, normal is going to be opposite and reciprocal. So opposite of positive 3 is negative 3, but then flip it, it's going to be negative 1/3. Okay, so y minus 1 equals negative 1/3 times x minus 1, and that's your normal line. So now we are defining one-sided derivatives. A function y equals f of x is differentiable on an interval close a to b if it has a derivative at every interior point of the interval, and the limits exist at the n points. So what we mean by this is the endpoints are unique, right? The reason for that is because, as you know already, guys, the endpoints are normally, we don't have a two-sided derivative. So here's a closed dot, here is, I made this too long, so let's delete this a little bit. Not because there's anything wrong with that, but it's kind of off my grid, so there you go. Close both a and b, okay? The endpoints normally don't have a two-sided limit, so they always have their own definition. So as you can see here, we have a on the left side and b on the right side, okay? So let's talk about right-hand derivative. Okay, so let me just make this box over here. Make sure this, okay. Right-hand derivative. The limit as h is approaching 0 from the right, f of a plus h minus f of a all over h. Okay, so if a is there, let's use a different color. A little bit distance, right? This could be called a plus h. Okay, and we want this h value to be super close to 0, right? Because we want this nearby point to be as close to a as possible. Similarly to this side, b is the endpoint on the right side, so we want this point to be b plus h. Okay, something super close to b, where h is approaching 0. Left hand derivative. As you can tell, guys, the definitions here are not any different from what we have already studied. So the limit as h is approaching 0 coming from the left side, f of b plus h minus f of b all over h. Example 7 says use one-sided derivative. Show that means we're proving, okay? The function f of x equals, we have piecewise here, 2 pieces as a matter of fact, x to the third only when x is less than or equal to 1, and 3x is when x is bigger than 1. Does not have a derivative at x equals to 1, so this is a proof. So let's find out what y is when x is 1. F of 1. This is the only piece that has containing x equal to 1, so 1 to the third is 1. So we have a point at 1, 1. So let's do the right-hand derivative. And then we want to do the left-hand derivative. Remember, if they don't equal, then we know that it doesn't exist, okay? So the limit as x is approaching h from the right side, f of a plus h minus f of a all over h, okay? So in this case, guys, a is always 1, f of a is always 1 as well, because f of 1 is 1, okay? So the limit as h, oops, look at that, guys. Sorry, this is h approaching 0 from the right. H is approaching 0 from the right. F of 1 plus h minus f of 1 all over h. So we're coming from the right side, okay? Remember, we're coming from the right side. So which piece are we using? First or second? Okay. Hopefully you guys said the second piece, right? Because it's 3 times 1 plus h minus f of 1 doesn't ever change because that's your algebra value. This equals 3 plus 3h minus 1 all over h. So the limit as h is approaching 0 from the right, that's going to be 2 plus 2h, I'm sorry, 3h all over h. So this side we can split it up to 2 over h plus 3h over h, okay, which this will allow us to cancel out the h here. So we have the limit as h is approaching 0 from the right, we know is 2 over h, okay, plus 3 in the front. What if we get h to be something super small, like positive 1 over 1,000, right? So it's 3 plus 2 over 1 over 1,000. This right here goes towards infinity. So this whole thing right here, guys, is going to go towards infinity. So it doesn't exist, but it does give us a behavior, okay? It's getting steeper positively. On the left side, we're going to go limit as h is approaching 0, and I keep writing x from the left side. F of a plus h minus f of a all over h, very similar, f of 1 plus h minus f of 1 all over h. So the limit coming from the left side, guys, is going to be using this top piece. So 1 plus h to the third power. Let me unfreeze. There you go. 1 plus h to the third power minus 1 all over h. So this allows us to distribute. Okay, so now if we write this out 3 times and FOIL, okay, it is going to come out to be 1 plus 3h plus 3h squared, then plus h to the third. Now I have to drop this minus 1 back all over h. Those are going to be gone. Factor out an h because that way we can reduce with the denominator. Then we got 3 plus 3h plus h squared all over h. Those are going to be reduced. Now keep in mind that h is approaching 0, so these are gone. So now we have 3. Okay, so the slope is coming from the left side is 3. The slope is coming from the right side is not 3. Whatever that is not 3, so these are not the same. So let's pinch it in and write our final answer. Okay. The derivative does not exist at x equals 1 because the left and right derivatives are not the same.